Students, we're going to be starting here on page 4. As you are watching this video, it's very important that you turn off all distractions, including your cell phone and Facebook and Twitter and YouTube and any other device electronic that might distract you at the moment. I'd also like you to please fill out where you are watching this video and the date and time. The date and time that you are watching this video. You're going to need a pencil and a straight edge and colors. We're going to do a review problem first, page 5. It says here, you're given the end point of a segment and its midpoint. Find the other end point. That is what you were looking for. Find the other end point. So here's an end point at 4, 4. And then we're given a midpoint of -8 and 5. -8 and +5. So we're told that this is a midpoint between two other segments. And you can see if this is one endpoint, the other endpoint is somewhere over here because we want to create congruent segments. So we have a mystery X and a mystery Y here for the other endpoint. The simplest way is to keep in mind that a midpoint means the middle. So one thing you can do is you can find the distance between here to here, the units. From 4 to 0 is 4. From 0 to -8, the distance here is 12. So the distance from here to this endpoint must also be 12. And you must note that we're going down the number line, at least as far as X is concerned. So -8 and 12 units to the left is going to put us here at our other endpoint at -20. And then here we're going to go 4 to 5. That's obviously +1. Again, it's 1 unit. And we want to find what that midpoint would be. That's 1 unit as well. Notice we're going up the number line, or positive, which means we're going upward on the y-axis anyways. So we have 5 plus 1, and our coordinate is 6. So our other endpoint is going to be approximately -20, +6. Endpoint of -20, +6. The easiest way to check this is to simply put it in the midpoint equation. Midpoint equation, you average the x's, divide by 2. You average the y's, divide by 2. Let's check that. 4 plus -20 divided by 2, comma, and 4 plus 6 divided by 2. This is going to be -16 over 2. This is 10 over 2. And this is -8, 5, which is your actual midpoint. That is your check. When we talk about similarity, and the key words you need to be familiar with are ratio, proportion, similar, scale factor, extremes, and means. Definition of a ratio is a comparison of two numbers by division. So we're comparing two numbers which are divided by. The most common ratio, comparison by division, is a fraction. So when we have 3 over 4, that is a ratio. You also need to recognize 3 other versions of ratios. One which is words, which we could use 3 to 4, 2 being the comparison. Also the colon, 3 to 4, very common on dilution of chemical substances. 3 over 4 as a fraction, and then a decimal, you need to think 3/4 of a dollar, which is 0.75. Those are all ratios, comparison by division. When you have an equation of two ratios, for example, if I have 12 over 16, which reduces to 3 over 4, The fact that I have two ratios, there's a ratio, and there is a ratio, and they are equal, that is an equation. This whole system here is called a proportion. And a proportion is an equation of ratios. Equation meaning equal. Let me give you an example. If we have here 2 over 3 equals 10 over 15. This would be a proportion, the whole thing. Now we're going to order from least to greatest. The least is 2, and the next one is a 3. The next term is a 10, and the final term is 15. Let's bring those orders back over to the next page. In that proportion, 2 over 3 equals 10 over 15. The lowest is 2. The next lowest is 3. The next one is 10. And the highest is 15. The means are what are called the middle terms. The middle terms of this order, that's called a means. I'd like you to write those down, 3 and 10. The extremes are the extreme beginning and the extreme end. We're going to go 2 and 15. Please write those down. Those are called the extremes. Now we're going to multiply these. 3 times 10, of course, is 30. 2 times 15 is 30. So what you notice here is that when you multiply the means, 30, and you multiply the extremes, 30, you get the same thing. You guys know this as cross multiplication. So if something is a true proportion, if you're going to test a proportion, the product of the extremes needs to be equal to the product of the means. The cross products must be equal. So if you want to solve for a true proportion, proportions are solved by cross multiplication. Let me give you an example. We have 4x plus 3 over 12 equals 5 over 4. We want to find a value of x so that we get a true proportion here. So, of course, we're going to cross multiply. When you cross multiply, it is very, very, very important that you never do the distributive property in your head. So this is going to be 4, parentheses, 4x plus 3, close it up, equals 12 times 5. Notice I did none of the multiplication in my head. Always write it out longhand. Now, physically draw your distribution arrows and do your next line. 4 times 4 is 16x. 4 times 3 plus 12 equals 12 times 5, which is 60. We're going to minus 12 both sides. And we get 16x equals 48. Divide both sides by 16. We get x equals 4. Now, it's always important to actually check this and see if it works. So we're going to take this 4 and we're going to plug it in right here. 4 times 4 is 16. Excuse me, 48 divided here is going to be 3, not 4. That's 12 is 4. So we're going to call this 3. We're going to plug this 3 in here. 4 times 3 is 12. 12 plus 3 is 15. So we have 15 over 12. That does. 3 goes in the top 5 times. 3 goes in the bottom 4 times. So check. Now it's a true proportion. I'm going to talk about similarity. Similarity. The basic definition of similarity is items which have the same shape but a different size. Same shape, different size. The most common example of similarity is when you're clothing shopping and you have a small, medium, and large of the same clothing item. It's the same shape item, just a small, medium, large. It's a different size. Same shape, different size. We would call all 3 of these polos similar. And the symbol we would use for similar is this symbol right here. Similar means same shape, but a different size. Same shape, but a different size. In mathematics, we're going to use this specific definition of similarity. It's going to be called scare. Similar, scare. S-C-A-R-E. And scare stands for this. Similar shapes have congruent angles and side ratios which are equal. Similar shapes have congruent angles which had and side ratios which are equal. That's scarce. Similar shapes have congruent angles and side ratios which are equal. So we're given here that these 2 shapes are similar. How do we know they're similar? Well, first we see that they have their angles. Their matching angles are congruent. The corresponding angles are congruent. So all the corresponding angles are congruent. That's the first check. And then the second, I check this ratio is a 1-to-2 proportion. This ratio is a 1-to-2 proportion. This ratio is a 1-to-2 ratio. And this ratio is 1-to-2. So we see here that the corresponding angles are congruent and all side ratios are equal. That means they are similar. A scale factor is what we just did in comparing the side to the side. When we compare side to side, we would call that scale factor. A scale factor is a ratio of one side over the other side of similar shapes, or side to side. So in these shapes here, the ratios of the side, 4 to 8, 2.8 to 5.6, and 6 to 12, we would all say that has a scale factor from top to bottom of 1 to 2. Scale factor, which is 1 to 2. When you're working with similar shapes, and you know that the ratios are equal, when you have equal ratios, by definition, that is going to be called a proportion. Equal ratios mean you have a proportion. When you have proportions, you can use them to solve. This is about 80% of this next chapter, is simply being able to solve proportions. For example, we take a look here. We first want to find what is the scale factor, and we're going to go from left to right. So I choose two sides which are in the same position, left to right. And I'm going to reduce that. That's 9 to 6, or I could go this way, 9 over 6. I reduce. 3 goes in a both. That's 3 to 2, or 3 over 2. So my scale factor is 3 to 2, or 3 over 2. Now I'm going to use that 3 over 2 as to solve for my proportions. So I go left to right, is going to be equal to the ratio of left to right. I have to keep the same order. So I'm going to go 21 over unknown. Now you cross multiply, and I'm going to have 3x equals 2 times 21. I'm going to divide both sides by 3. And I'm going to get x equals 14. So my unknown side here would be 14. Now we're going to have a practice here. We're going to start with 3 ratio questions. So we have here, we're going to write this ratio of 44 centimeters to 2 meters in simplest form. Let me tell you what this ratio is not. It is not 44 to 2, which would reduce to 22 to 1. Both of these, be very careful, are incorrect. The reason why they're incorrect is you have to make sure you have the same units before you can make a comparison. You have to compare apples to apples and not apples to oranges. You have to have the same units. So before we can make our comparison, we need to convert meters into centimeters. And we know centi means 100, so for every 1 meter, we know that that's going to be 100 centimeters. So if we have 44 centimeters to 2 meters, that's going to become 200 centimeters. Now I have the same units. Now we can compare apples to apples. So I have 44 over 200. 4 goes in here 11 times. 4 goes in here 50, and that's as far as we go. So our ratio is going to be 11 to 50, or 11 over 50. Also, when you're dealing with ratios, you need to watch out for keywords. Keywords. The word 2 becomes a fraction, and is an equal sign. So we have 3 to an unknown. That's 3 to an unknown is, that's an equal sign, as 18 to 24. That's what this translates to. 3 over unknown equals 18 over 24. Now you want to cross multiply. Now I have 18x equals 3 times 24. Rather than multiplying out, I'm just going to divide and reduce. 6 goes in here 4 times. 6 goes in here 3 times. 3 goes in here once. So the final answer here is going to be x equals 4. Now let's see if this actually works. We're going to go 3 over 4 equals 18 over 24. Since 6 goes into here, 6 goes in there 3 times, 6 goes in there 4 times. That is our check. The x is 4. Another common ratio question is if we have 2 supplementary angles which have a ratio of 3 to 2, find the measure of the angles. So here we have angles. We'll call this angle A and angle B, and they have a 3 to 2 ratio. Well, this is really simple. When you have a 3 to 2 ratio, it means this was 3 of something and this was 2 of something. Has to be the same something but reduce. So 3 of something and 2 of something is 180. So we're going to do this. 3x plus 2x equals 180. 5x equals 180. So we're going to do 180 divided by 5. We get x equals 36. So 2 times 36 is 72. 3 times 36 is 108. And that will reduce to a 3:2 ratio and add up to 180. It says the following images are similar. Solve for the unknown. Well, we'd have to make our scale factor from A to B, and notice the order that we're going here is from A going to B is 2 to 3. So first, we're going to make a 2 to 3 ratio, and then we have to compare small to large, left to right, and that's going to be x plus 3 over 21. Again, left to right, because that's where the scale factor is given. Cross multiply, you can never do the distributive in your head. So this is going to be 3 parentheses x plus 3 equals 2 times 21. Now you distribute. And x equals 11. Now let's actually plug that in and see what happens. If x equals 11, 11 plus 3 is 14. So we're going to have 14 over 21. 7 goes into 14 twice. 7 goes in here 3 times. There's your check. It matches our 2 to 3 ratio. X equals 11. For this one, our scale factor from A to B, now notice the direction we're going here. A from here to B going this way is a 3 to 7 ratio. Now notice the order that they want you to go this way. So it's 3 to 7. Keep in mind that's an A to B ratio. A to B. Now we have to match. Is going to be 36 over 3x plus 27. Now you cross multiply. 3 times 3x plus 27 equals 7 times 36. Distribute. We're going to get 9x plus 81 equals 7 times 36, which is 252. We're going to minus 81 both sides. We're going to end up with 9x minus 81 is 171 divided by 9, and we get 19. So we want to determine if the images are similar. Remember, similar means we're going to have congruent corresponding angles. So I'm going to write congruent angles and ratios which are equal. So our ratios must be equal. So we're going to check for both in all 3 scenarios. Okay, so the first one, we can see that we have ratios equal. Now let's check, the angles are equal. Let's check the ratio. 4 to 6. So we just do 4 divided by 6, and it's a 0.66 repeating. So 4 divided by 6. And now let's try this one. Let's do 2.6 and 7.7. That's a 0.33 repeating. Now, because the ratios are not equal, these first sets we would say is not similar, because the ratios are not equal. Let's check the next one. We can see that the angles are congruent, so that does work. Now let's check our ratios. Our ratios are 12 to 4, 6.9 to 2.3, and let's divide and see if we get the same ratios. So 12 divided by 4, of course, is 3. 6.9 divided by 2.3 is also 3. So the ratios are the same, so we would say the second one is similar. The third one, again, are the angles equal? Yes, they're all right angles. Let's check the ratios. We have 12 to 6, which of course is 0.5, and then 8 to 5. That's not 0.5, obviously. So we would say this third one is not similar.